separating technique, we are going to look at crystallization. Crystallization is very, very similar to evaporation, but with evaporation, what we did was we removed all of the solvent or the liquid, and we're just left with very fine salt particles in our example. But if we would like to form bigger crystals, we need to do that slightly slower and in a slightly longer process, and that is called crystallization. So again, it allows us to separate a soluble solid from a solution, but this is when we want to collect bigger crystals. And you'll meet this at different points of your course in the likes of acids, bases and salts, where you prepare crystals and things like that. So what I have here is a solution of copper sulfate solution. So that's copper sulfate dissolved in water. And you can see that it's a nice blue colour. All copper 2 salts in solution are blue. So what I'm going to do is I'm going to pour some of this into an evaporating basin. And practically speaking, this method is identical to evaporation, certainly for the start of it anyway. But what we want to do when we want to make bigger crystals is we want to do this process a little bit more slowly. What we want to do is just evaporate some of the solvent or the water off until we get what we call a saturated solution. And a saturated solution is one in which no more of our solute or our copper sulfate will dissolve. So we want to get it at the point where it's completely saturated. A bit like when you are making a cup of tea and you want to put some sugar in. You can keep putting sugar in and trying to stir it to dissolve it, but at some point no more sugar will dissolve, and that at that point you could say your tea has been saturated with sugar and your solution is saturated. So we want to get to that point with our solution here. So at the minute, if I tried to dissolve a wee bit more copper sulfate in this solution, it would probably dissolve. But if I evaporate off some of the water, we'll get to that point where the solution is saturated, where no more of our solute will dissolve. So what I want to do is I want to turn my Bunsen burner on. You can see exactly the same setup as evaporation, because we're essentially doing the same thing. We're evaporating some of our solvent off, but this time I don't want to evaporate all of the solvent off. I want to evaporate it until about half volume, where my solution will be saturated. So I'll still have a solution, but it will be saturated. So I'm going to turn on my Bunsen burner. Okay, there's it lit now. And what I want to do is I want to make sure that the flame is nice and gentle. I want this essentially at the coolest possible flame, but not a safety flame. If I take this out for a second, safety flame would be this one. This is the coolest possible flame that we can have on our Bunsen burner, but it's quite sooty, so it would make the evaporating basin quite sooty. So I want to open the air hole slightly to get our nice clean blue flame. But I don't want it on a roaring flame. This is a roaring flame. It's very, very hot. It would evaporate off our solution very, very quickly, and we wouldn't get nice crystals forming. So I want it to be blue, but a nice gentle blue flame. And what I can also do is turn it down a little bit at the gas tap, so that it's not just quite as strong a flame. Okay, so what I'm doing is I'm heating this solution very, very gently till about half volume, and then what we will do is we will leave this solution to cool and crystallize. And what happens is that when a solution cools, the solubility of our solute, our copper sulfate, will decrease as the temperature decreases. So we'll not get as much dissolved, and that's when we'll start to see our crystals forming. So I'm going to leave this to evaporate some of the water off, about half volume approximately. We'll not sit and watch this because it could take quite a long time, especially since we're doing this nice and gently. And then we'll have a look at our saturated solution, and then we'll leave it overnight. So we can see now that our solution has been evaporated to half volume. This solution is now saturated, so what we will do now is we will leave this to cool and crystallize. Generally we leave it on a windowsill for a little bit more of that water to evaporate slowly, and the crystals will form as the water actually bonds to the copper sulfate molecules. And what we have here is one that we have done earlier, and you can see that we've got crystals forming at the bottom of the solution. You'll still end up with a little bit of the solution left in your evaporating basin unless you evaporate more of it off. But you can see there at the bottom, if I kind of pour some of this solution away, I'll get a glass rod to help show some of these. You can see our nice big crystals of copper sulfate have formed, and that's from when our water molecules have actually bonded to the copper sulfate molecules, and they have formed these lovely blue crystals, and that is formed by a process of crystallization. If we had used evaporation, we wouldn't have got nice blue crystals. We would have just got like a pale blue powder form if we evaporated all the water off. So this is what is produced after leaving our saturated solution overnight on the windowsill to form nice crystals. So that is the method of crystallization.